Okay, guys, so today we're going to talk about ratios and proportion. This is chapter 7. We're going to define what a ratio is. We're going to take a look at some examples this morning. Um, Try and follow the slideshow. We're not going to do every slide, but let's start with this first slide on a ratio. So we say that a ratio is the comparison of two numbers by division. The one thing I'll point out to you is we're looking at a ratio. A lot of times we look at it in terms of a fraction, but we always want to make sure that we simplify the ratio if at all possible. So just like this example here on the page, 8 over 12, just like with a regular fraction, simplifies to 2 over 3. When we write a ratio, there are basically three ways that we can write a ratio. The first one is like we just showed you with a fraction. Sometimes we use a colon, so the ratio of A to B. Sometimes we use the word 2 in between, so A to B. In terms of, there are some different things that you might notice. I think with a colon, a lot of times we use a colon when we're talking about odds. If I say the odds of winning the lottery are 1 to 287 million, which I think is about the odds of winning. That's the Powerball. Just recently, I don't know if you guys paid attention to the Powerball, but just recently it got up to almost $1 billion jackpot. I think it was about 900 million. And somebody, I think, finally from one winner, I think, was it Maryland? Yep. So 1 to 287 million. That's a pretty high chance, or pretty low chance, I guess, of being able to win in that case. Using the word 2, sometimes we're comparing just different things. We'll use that instead of writing it as a fraction. Let's take a look at an example. So again, as we said, a ratio used to compare two numbers. In this case, we're going to compare two side lengths of a sheet of plywood. So it says a sheet of plywood is 0.5 meters long by 35 centimeters wide. It says find the ratio of the length to width. Now, one of the things, and this is in bold, is we want to make sure in most cases that our unit of measurement, if we're comparing the same thing, in this case two distances, it's always good for the unit of measurement to be in the same unit. So here we've got 0.5 meters and 35 centimeters. So we kind of have two choices here. We can change the 0.5 meters to centimeters, or we can change the 35 centimeters to meters. Last class decided it'd be best to move the meters to centimeters. And just to review our conversions here, we know that there's 1 meter is the equivalent of 10 decimeters, which is the equivalent of 100 centimeters. So if I were going to take 0.5 meters and change it to 100 centimeters, all I have to do is move the decimal place 2 places to the right, because I'm going from meters to centimeters. So that would be the equivalent of 50 centimeters when I move the decimal. Now it wants me to write a ratio of the length to the width. So 50 centimeters is the length and 35 is the width. 50 over 35. If I reduce that, can somebody tell us what 50 over 35 would reduce to? Aiden, go ahead. 10 over 7. and that would be my ratio if I were leaving it in fraction form. Again, I could say 10 to 7, or I could actually use the word 2. So all three of those would be acceptable ways to write your answer there for that one. Any questions on solving? Okay, let's move to a new example. It says two complementary angles have measures in the ratio of 2 to 7. Find the measure of each angle. Now, these ratio problems where we're dealing with the angles in a figure, or we're dealing with complementary or supplementary, we're basically going to create an equation to solve these. So the first thing is we have to know, what's the word complementary mean? Can somebody tell us what the word complementary means? Chloe? Yes. So it means that the angles together are going to add up to 90. So if I have a ratio of the angles of 2 to 7, all I'm going to do here is I'm going to add a variable. So I'm going to say 2x plus 7x equals 90. And then I'm going to go ahead and solve the equation. So 2x and 7x is 9x. And that equals 90. If I take and divide by 9, that tells me that x is 10. Now the question's asking us to find the measure of each angle. So what we're going to do is we're going to take the 10, we're going to plug it back in for x. So if I do 2 times x, or 2 times 10, one angle is going to be 20 degrees. And then I do 7 times x, which is 7 times 10. That gives me 770 degrees. And again, the thing I like about these problems is you can always check to see if your answer is right or not, because these two angles should add up to 90. 20 plus 70 equals 90. So we know that we've done that correct. We're going to take 11x plus 7x plus 5x plus 4x plus 3x. Now, on this one, we have to determine what are we going to set that equal to. Like I said, as he said, we're using that formula, n minus 2 times 180. So because a pentagon has 5 sides, 5 minus 2 is 3. 3 times 180, that gives us 540 for the sum of the interior angles. So here's what I want you to do right now.
Actually, Steve Faulkner's doing that with me.
Yeah.
Essentially, staff use that.
Okay, let's go ahead and go through it here. Hopefully, as you went through this, you add together your x's. So 11 plus 7 plus 5 plus 4 plus 3. And I hope you came up with 30x when you added those together. That equals 540. And then we're going to take and divide by 30. We divide by 30. 540 divided by 30 gets us 18. Then we're going to take 18 and plug it in for x. So 11 times 18. Hopefully you got 198. And you do 7 times 18. And that should have gotten you 126. and then 5 times 18, and that would have gotten you 90, and then 4 times 18, and that would have gotten you 72, and then 3 times 18, and that should have gotten you 54. Show of hands, how many of you got all 5? I'm going to move on to proportions. So we say a proportion is simply two ratios that are equal. So 2 equal ratios. So in this case, A over B equals C over D, or in number form, 3 over 6 equals 1/2. The main thing that we're going to be doing with these problems is solving the proportions. And I'm sure you probably have been solving proportions since you were probably middle school age, I hope. Basically doing cross multiplication. When I'm doing cross multiplication, I do have to focus on 2 fractions where there's only one unknown. In other words, I wouldn't be able to put x equals 16 and y over 40 and be able to solve that problem. So I'm going to solve the first one over here to the left first. So what I would do is I would do 3 times 16, and then 8 times x. I know that 3 times 16 is 48. And then if I divide by 8, x would be equal to 6. Now somebody last period raised a good point here. They said, well, if I know that 16 is twice 8, can't I just take 3 and multiply it by 2? And the answer to that question is yes, you can. But the thing I'll point out to you is I think doing the cross multiplication will always work. You know, if this number 16 were an odd number, like let's say 15, you know, the relationship between 8 and 15 is not quite as easy to determine what I multiplied by to get that 15. So doing the cross multiplication is probably the best thing. If I'm going to solve for y, now I'm going to just put together the first fraction with it. So I'm going to do 3/8 and y over 40. Well, 3 times 40 would equal 8 times y. I'm doing my cross multiplication again. Well, 3 times 40 is 120 equals 8y. If I divide by 8, y is going to be 15. And again, that maybe was another one that you could have done the multiplication. 8 times what gives me 40? Well, 8 times 5, and 3 times 5 would give me my 15.